Hi everyone, let's look at trends along homologous series. So if we consider the alkane homologous series, as the length of the carbon chain increases, the boiling point is going to increase. So when carbon number increases, what happens is that you have more electrons in the molecule. So when you have more electrons in that substance, means that you're going to have more van der Waals interactions. And more van der Waals interactions means that there is more intermolecular forces, hence the boiling point increases. So alkanes, they are non-polar molecules, and the intermolecular forces are van der Waals forces. When the molecular size increases, number of electrons per molecule increases and van der Waals forces become stronger. When van der Waals forces become stronger, definitely the boiling point is going to increase. And normally, if you look at the alkanes, as the number of carbon atom increases, the state at room temperature changes from gas to liquid to solid. Generally, carbon number, so compounds having 1 carbon to 4 carbons are gases. 4 carbons to 15 carbons are liquid, and then more than 15 carbons are solids. Also, straight chain alkanes will have higher boiling point. When the alkane is a straight chain, means there's going to be lots of interaction between the chains. The chains are in contact with each other. There's large surface area in contact. Therefore, the van der Waals interactions are very extensive. Compared to branch molecules, will generally have like an almost spherical shape. And because of this shape, it reduces the area of contact, and therefore you have less surface area of contact. And hence you have less van der Waals forces. Hence, these branched molecules will generally have lower boiling points than their straight chain counterparts. Now, the second trend that we'll see is the volatility. Now, volatility is ability to produce vapors. So generally, something that has a low boiling point will produce vapors easily. Something that has high boiling point will be less volatile, will produce vapors less easily. Alkanes are non-polar, so the only intermolecular forces are van der Waals forces. Halogenoalkanes, they contain a halogen atom. Aldehydes, they contain an oxygen atom. And ketones, they contain also an oxygen atom. And generally, these molecules, halogenoalkanes, aldehydes, and ketones, they have dipole-dipole interactions because of the electronegative element attached to them. So halogenoalkane, halogens are generally more electronegative than oxygen, unless you're considering a halogen that is less electronegative than oxygen. Then the order is going to be different. But here we're considering when the halogen is fluoroalkanes. So if the halogen here is, for example, chlorine, then most probably the order is going to be different. Then the aldehyde and the ketone will be higher than the chloroalkane. But for fluoroalkane, the aldehyde and the ketone will be lower than it. So alcohols, they have an OH group. Carboxylic acid, they have a COOH group. So in both of them, you have hydrogen bonding. In carboxylic acid, because you have that CO and then OH, so there's going to be hydrogen bonding with both the oxygen and oxygen here and also here. So as we're moving in this direction, there is an increasing strength in intermolecular forces of attraction. Hence, there is an increasing trend in boiling point, which explains the volatility differences.